Okay guys, today we will discuss on the operations on exponent of real numbers. This is very easy topic as in your earlier classes you have studied about that. So the basic things are like that. The real numbers will be of this type: base and power. This is base, this is power. This is power, okay, and it is also called exponent. Means this power is called exponent and this is base. So the real numbers will be of this type: 2 power 4. What would be? That is 16. But if we say 2 power 3 by 2, then what would you do? We don't know what its value will be. Okay, so we will discuss on the operations, how they these type of real numbers are solved. There are some laws, like the first point is, you can say, product law. Means if you have same base and different power or same power, and the operation is multiplication, then the base would be the same, that is common, and power will add. This is first operation. Means if base same and power may be same or different, that does not matter, but after operation we will get a single index, that is that base is a and power will be m plus n. We can take example of this. For example, if you have base 5 power 3, base 5 power 4, base 5 power 6, here we see all the numbers have same base, that is 5, and according to this law these numbers are in multiply form, so the power will get added. So this would be base 5 and power 6, 3, 9 minus 5, that is 5. Okay, so this is the operation. The second one is division. This is one, we can put it in box so that it is significant. The second one is of division: a power n and a power n. When divides these two type of numbers, then power will subtract to each other, means m minus n. Here we can take this condition. Why this condition? Because today we are not going to discuss the whole one. We are going just to discuss which is in the scope of this book. And scope of this book says that this a that we are taking, that is a real number, and in most questions it is positive real number, and the power must be positive. Means when operations end when this power is positive. Means this value, which is power of this base, should be positive. Means if I say, if we have 5 power minus 2, so can we leave it here? No, we should write it as 5 power 2, that is positive power. Okay, so when base is same and are divided, in this form, then powers will be negative. And if you take example for this, that is base 5 3, and that is base 5 and power minus 4, so base is same and operation is divisible, divisibility, law of divisibility you can say, then this power will subtract and you will get this number 5 for power 7. Okay, since the power is positive, so we can terminate this operation at this point. I think you will understand. The third one is when base is same, base is A and having power more than 1. Base is A and power is M. Again, the power of the whole function is N. Then these power will multiply to each other. So you can take example for this: 2 power 3, power 4, power 6. Any number of powers you can take. The base is the one whole and these power will multiply to each other. That would be 4 3 are 12, 6 are 7 2. Okay, this is the operation. I think you will clearly understand. The fourth operation we can take in the form where we have some indices like that. What is this? This is inverse of any number, means we say square root. What is square root? This is square root, that is 1 by 2. But if we write something here, that is cube, this is called cube root, that is 1 by 3. And you can take many values like that. You take here 5 here, so this would be 1 by 5. And in that sense we can write it as am power 1 by n. Okay, this would be m divided by n. So easy operations. I think there is no problem, and you can take example of this type of index as 2 power 3 by 4, and this can be written as 2 here 4 and here 3. Okay, so this is the operation. Now the fifth one, we should write it in box so that okay. Now the fifth one is if we have different base and same power. I said different base same power, then we can separate them as am bm. Here also am positive, and this operation is very important. As you see, you can take example of this type of number a b, and you can clearly write it as in different forms as a b, separate form you can say. And if it's reversed, then we can take example of reverse form. If we have root 2 and root 3 both are irrational, and as the base different and power same, so the power same, so come to the common power of this whole function, that is root, you can write here as 6. This is the only reason, because of this operation. Okay, the next one is division form, a divided by b, which can be written as am and bm. Okay, like multiplication, division can be performed in this way. You can take example of this as root 2 divided by root 8. As power is same, So you can take it as in the form the common root, and when you see this is 1 by 4 and this is 1 by 2, so this is the operation. So easy operations, not a difficult one. Some points you can remember. If any base having power 0, that value 1. Okay, but remember, if base is 0, then would it be 1? Think about it. You can put your query on our comment box. I will give answer to that question. So please subscribe our channel. And also click on bell icon to get the latest video of our channel. Please inspire us by clicking on like icon. Also, if you have any query or doubt, you can put it in comment box. I will try to answer that within 24 hours. So okay, keep in mind the base here, as I defined above, this base will be non-real number. I can say in this scope of this book, this base will be non-negative real number. Okay, non-negative real number. So don't try to take base 0. We have, I think, no question in the exercise also which have base 0. So I think now we have to come to the exercise. But before that, you can say if we take negative base, that is like that, in the form you can write it as -1 and that m, and these are two base, and we can spare them as so. Now come to the exercise. Okay, the first the exercise 1.6, and very small exercise, so video will be also very small. On the question 1, having 3 parts, we will try to take 1 or 2 parts. The first part is that we have to find the value of 6, 4 having power 1 by 2. So this is the base, this is the exponent. So base can be factorized, or you can write it as 2 multiply 2 multiply 2, 2, 2 and 2. Okay, that is 1 by 2. How many 2's are here? 1, 2, 3, 4, 5, 6. 2 power 6, 1 by 2. As I discussed, if we have one base and many powers, then these power will multiply with each other, and you will get this value 2, 3, and that would be 8. As power is 1, that is positive, so we can say it is complete. Another example, exercise question number 1 part, you can take 125 and power is 1 by 3. Very easy. The prime factors are 5, 5, 5, and we see base same 1, 2, 3, 1, 1, 1, that is 1, that is 3, and 1 by 3, and say 1 base and power more than 1, what do you get? That is power 1, and so that is the answer. Very easy. Now the question number 2, we have 9 power 3 by 2. 9 power 3 by 2. Again, factorize this. you will get 3 and 3, and 2 3s 1 1, that is 2. Again you see base 1 power 2, so multiply each other and you will get this number, that is answer. Very easy. Now we can take this part, 125 minus 1 by 3, that is 5 5 5, and you see that is 5 power 3. Again 1 base and multiply to each other, so you will get 5 minus 1, and I said power must be positive 1, so you have to take it as, that is the answer. End of operation. Question 3. The first part is that 2 power 2 by 3 into 2 power 1 by 5. Okay, so as you see, base same and this power will add. You can solve them by this way, as in your earlier classes you have done that. 5 2 are 10 plus 3, that would be 13. 2 power 13 by 15, which is positive, so you can end this here. Again we are taking third part, that is base 11 having power 1 by 2 and 11 having power 1 by 4. Again the by division operation, base same and power will subtract to each other. What would be that? 1 by 4, that is positive, so operation terminate here, and exercise complete. Thank you.